Hello everyone, let's start class 10th mathematics first chapter arithmetic progressions. So I'll be doing this whole chapter in three parts. So in part 1 we shall be discussing about the introduction of this chapter and what is arithmetic progressions. And in this I'll be solving exercise 1.1. Next in part 2 we shall be discussing about the end term of an AP and I'll be solving exercise 1.2 in this part. And the last part is part 3, in which we shall be discussing about the sum of first n terms of an AP, and parallelly I will also be solving exercise 1.3 and 1.4. I'll cover these exercises in this part. Okay, so now let's start part 1. So first, introduction of this chapter. So now we'll understand what is arithmetic progression. So you must have observed in nature many things which follow certain pattern, such as petals of sunflower. See, the petals of sunflower are similar, right? They follow pattern. Now, holes of honeycomb, they also have a specific structure. They follow the pattern. The grains of the grains on a maize cob also follow pattern. Then spirals on pineapple and on a pine cone, etc. Now, now let's look for some pattern in which occur in our day-to-day life. Some such examples are, so the first thing is, Reena applied for a job and got selected. So she has been offered a job with a starting salary of 8,000. So what's her first salary? The first year salary is rupees 8,000. Next, with an annual increment means yearly it increases by rupees 500. Okay, so initially she had rupees 8,000 for the first year. Now annually means for every year it got raised by rupees 500. So when she went for the second year, her annual salary was rupees 8,000. Monthly salary increased to rupees 8,500. And third year, it again got raised by 500 rupees, that raised to rupees 9,000. Now for the fourth year, it got raised to rupees 9,500. So here you can actually observe a pattern. Here each value is getting increased by rupees 500, right? So this is a pattern which you can observe in these numbers. Now let's look into the second example. Now the length of the rungs of ladder decrease uniformly by 2 cm from bottom to top. Okay, as you move from bottom to top, the length is getting decreased by 2 centimeter. The bottom rung is 45 centimeter in length. So they have given you this length, that it is 45 centimeter. I'm not writing the centimeter unit here. The length is now 45 centimeter. But as you move to the second rung, the length is getting decreased by 2. So what is happening to this length? Now this decreases by 2 to form 43 centimeters. Now the third rung again decreases by 2 to form 41 centimeter. And the fourth ring, what happens to it? 39 centimeter. Fifth rung is 37. So then I have first, second, third, fourth, fifth, sixth, 7, 8. Okay, let's find till 8th rung. Okay. So it's 37, again decreases by 2, 35. Then again decreases by 2, 33. Again decreases by 2, that is 31. And again decreases by 2, that is 29. So here you can again write the series, that is 45. Then the second got reduced by 2 to 43. Then 41, 39, 37, 35, 33, 31, 29. So here can you observe pattern? Yes, each of them is getting reduced by 2. So I can write minus 2. Here also minus 2, minus 2, minus 2, minus 2, minus 2. So here this is the pattern that you can observe, right? So now let's, so there are more examples given in your textbook. You can refer to them. There I have discussed only 2 examples. Now arithmetic progression. The same thing which we now discussed, it is just a number, series of number. Okay, and there is some condition. Let's study here. Now consider the following numbers. Okay, like 1, 2, 3, 4, and have given you 5 sets of numbers. Now each number in the list is called a term. So here 1 is a term. So this whole thing is called as a series, and each number in a series or in a list is referred to as a term. So 1 is a term, 100 is a term here, -2 is a term, 3 is a term. Any number in this whole list is referred to as a term. Okay. Now given a term, can you write the next term in each of the list above? So in order to write the next term, I need to understand the pattern. So if so, how will you write it? By understanding and analyzing the pattern, I can write the next term. Perhaps by following a pattern or rule. Now let's observe and write the rule here. First, let's write the rule. So here, if you observe here, each number is getting incremented or getting raised by 1, right? So can I write the next number? Obviously, it's going to be 5. The next one, 6, 7, 8. So easily I found out the next numbers. So here, what was the rule? Each numbers were getting raised by, each term was getting incremented by 1 in the series. Now here if you see, okay, I'm able to observe that here the numbers are getting reduced by 30, -30, right? So I found the pattern that the numbers are getting reduced by 30. So the rule for the second series is the terms are getting decreased by 30. So the next term is going to be -20. After that -50, and it goes on like -70, etc. Sorry, -80. Next it's -80 and it goes on. Next, let's move on to the third one. So here, what pattern can you observe? According to me, we are adding +1. We are adding 1. Again, for -2, if I add 1, I'll get -1. To -1, if I add 1, I'll get 0. To 0, if I add 1, I'll get 1. So this is the pattern here, right? So here, you need to observe the pattern, then you can write the next term. Now in the fourth example, okay, what if I add, you will get the next thing. It's just 0. I'm adding 0. So the pattern here is, we are not going to add anything. Or in other words, I can say we are going to add 0 here. So what about the next fifth term here? It's going to be 3. 3. That's it. Now here, the fifth example. So here if I add -0.5, then the series will be obtained. So what about the fifth term here? It's -3.0. After that it is -3.5 and so on. So here we observed the rule and the pattern, and then we wrote the next terms, right? So now based on our previous analysis, let's obtain the definition. So in all the above lists, we see that the successive terms are obtained by adding a fixed number to the preceding terms. Such a list of numbers is said to form an arithmetic progression, which we also refer to as AP. So what did you understand? So we are obtaining the next term by adding a fixed number to the previous terms. So here I obtained 10 by adding a fixed number to 40, and I obtained 40 by adding a fixed number to 70. So these numbers, fixed numbers that I'm adding, can either be positive, negative, or 0. Okay, there's no condition on the fixed number, but the number you're going to add or subtract must remain fixed. You need to note down it is fixed. So this is AP. So an arithmetic progression. So what is arithmetic progression? It is a list of numbers. So this itself is your AP. So these were basically your 5 examples for AP. So an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term, except the first term. So the first term is independent. You basically have a first term. So here in 1, 2, 3, 4, the first term, I can't say anything about it. But for the second term, I actually obtained it by adding 1. So we add a fixed number to the preceding term to obtain the succeeding term. Okay. Hope you understood this. Now, the fixed number that we add is given a special name, that is common difference. Okay, we call it as common difference. So here in this example, I am adding the number 1. So what can I conclude from this? This number 1 is the common difference. This one is the common difference. So in the fifth example, I am adding 0.05. Then 0.05 is the common difference. In fourth one, I am adding 0 to 0. So 0 is my fixed number. So that is a common difference. Now this common difference is actually represented, instead of writing this whole big words, a sentence, I can just simply represent it by small letter d. So this represents your common difference. Okay, and this common difference can either be positive, negative, or 0. Okay, you also need to note this down. So here, in this case, it's positive. In the second case, it was negative, and in the fourth case, it was 0. Next, representation of an AP. So AP, okay, simply I can represent the first term as A1. Okay, we usually represent the first term as A1, the second term as A2, third term as A3, fourth term as A4, fifth term as A5. Now, how long can I write? So we just put dots for infinite if it continues. And the last term, if I have it, then I represent it as an. So this is the nth term. Okay, nth term. So it can even be a 10th. If it is a 10th term, it will be A10. If it is your 18th term, it is A18. If it's your 100th term, it will be A100. So n is a last term here. So this was your first term, this was your second term, and A3 was your third term, A4 was your fourth term. Okay. Hope you understood this. The representation of an AP is clear to you. Okay. Okay. So now here find the first term and the common difference of the following APs. Okay, you have to find the first term. So the height of some students in the school of a school students standing in a queue in the morning assembly as is given to you. Okay, so if the first term is obviously the first one, so here first term I'll be representing it with A1 and the common difference with D. So here A1 is equal to 147. Now what is the common value that I'm adding here? I'm just adding 1. Second case again I'm adding 1. So what is the fixed number you're adding? The fixed number is your common difference. So here the common difference is 1. So D is equal to 1 or plus 1. Okay, you can not specify, you can also use plus symbol. Next, the B part. The minimum temperature in degrees Celsius recorded for a week in the month of January in a city arranged in ascending order are. Okay. So this is a minimum temperature which is recorded for a week in the month of January in a city. So it's minus 3.1. Obviously, always A1 is going to be a first term of the series, that is minus 3.1. Now we have to find the common difference. So how do I find the common difference? I need to find the fixed term here. Okay. So here I'm just adding 0.1. Right? If I add 0.1, then I'll get the series. So the common difference here is plus 0.1. Next, the balance money in rupees after paying 5% of total loan of rupees 1000 every month is, so this is the balance money. So here obviously the first term is 950 rupees 950. Now here I'm just adding 50, sorry, I'm subtracting 50 minus. So this is the fixed number. So your common difference here is minus 50. Now the next question. Cash prizes in rupees given by a school to the toppers of class 1 to 12 are respectively 200, 250, 300, etc. has got the 750. So here the first term is how much? First term is rupees 200. Now the common difference. So if you observe here, for each term I am adding 50. So the common difference here is rupees 50. Next question. The total savings in rupees after every month for 10 months when rupees 50 are saved each month are, so they have given you the series. So find the first term and the common difference by yourself. It's very easy. Next thing is a general form of an AP. So we saw that the representation of AP is A1, A2, A3, A4, A5, and yes, it goes on. Okay, but if you observe, if I consider A1, what about A2? A2 is nothing but I'm adding a common difference to the first term. So I can write A2 as A1 plus some common difference. See, I'll consider a series 2, 4, 6, 8. Okay, so here it is A1, A2, A3, A4. Okay, so now here your first term is as it is, but what is your second term? Your second term is nothing but, so what is the common difference here? Here the common difference is equal to 2. So but I can write this as 2 plus 2, that is A1 plus your common difference. Now if I move on to the third term, okay, so I can write it as A2 plus D, because it is A2 is 4 plus D is 2. Now if I discuss about A4, I can write it as A3 plus D, because we are adding a common difference D to the previous terms. So that is 6 plus 2, that is equal to 8. So from this I can tell that your A2 is A1 plus D, A3 is A2 plus D, A4 is A3 plus D, and A5 is A4 plus D. Correct? Okay. So how did I write this? By telling you that A2 is equal to A1 plus D, A3 is equal to A2 plus D, A4 is equal to A3 plus D, okay, and A5 is equal to A4 plus D. Okay, fine. But now again, A1, okay, A1 plus D. But in place of A2, can I write this again? In place of A2, can I write this again? So what is your A2? Your A2 is nothing but A1 plus D. Okay. This is your A2 plus D. Now, in place of A3, I'll write A2 plus D. In place of A3, I'll write A2 plus D. In place of A3, I wrote this plus D. Now, what about A4? Your A4 is nothing but A3 plus D. Okay. In place of A4, I wrote A3 plus D plus D. So, this is nothing but A1, A1 plus D, A1 plus 2D, A2 plus 2D, A3 plus 2D. Now, again, if you observe here, I can write this A2 as A1 plus D plus 2D is this one. Okay. Now again I can write A3 as A2 plus D plus 2D. So this term became A1 plus 3D. Now and here this term became A2 plus 3D. Now again here in place of A2 I can write A1 plus D, and this is plus 3D. So that is equal to A1 plus 4D. So this was your A5, and this is your A4, and this is your A3, this is your A2. So this is your A1. So finally I can write this whole series as A1, A1, A1 plus D, A1 plus 2D, A1 plus 3D, A1 plus 4D, and it goes on. Right? So this is your first term, this is your second term, this is your third term, this is your fourth term, and this is your fifth term, and it goes on. Okay, so if you observe one thing, so whatever is your term, one less than that you will be writing in front of your common difference, and you will be adding it, right? So from this, can you predict your a nth term? A nth term, a nth term, that is equal to your first term plus, you have to subtract this by 2 and multiply this by d. So this is your formula for your nth term. This part I'm actually going to discuss in your part 2, but since this topic came here, I just thought it's better to discuss this thing here only. Okay, it's actually a formula, but see, the reason for this is this one. How I obtained this is from this topic. So this is your general form of an AP, A1 plus D, A1 plus 2D, A1 plus 3D, and it goes on. Okay, now what happens if I subtract A1, A2 minus A1? If I do A2 minus A1, then what will happen? Let me see that. Okay, so here, if I do A2 minus A1, now what is A2? It is A plus D, A1 plus D. And what is A1? It is A1. So what will you obtain? Will get D. Now if I subtract A3 minus A2, practically think you will be getting the common difference only. If you are not able to understand, just observe this. A3 is A plus 2D, A1 plus 2D, and A2 is minus A1 minus D. So what will you obtain from this? You will be obtaining common difference D only. So always the common difference is equal to the difference of the two consecutive terms. So A2 minus A1 is equal to A3 minus A2. It is equal to A4 minus A3. It is also equal to A5 minus A4. So that is also equal to AN minus AN minus 1. So all these things are equal to your common difference D only. Okay. Hope this is clear to you. Now let's move on to one more topic here, that is what is finite and infinite AP. Okay, so the finite AP means all those arithmetic progressions which have finite number of terms. So here I'll consider an AP, say 2, 4, 6, 8. So how many terms are there in this AP? 1, 2, 3, 4. So there are basically 4 terms in this AP. There are 4 terms in this AP. So this is a finite AP. Then what is an infinite AP? So I'll consider an AP, say 2, 4, 6, 8, 10, and I'll be continuing it. So instead of writing the whole thing, I'm just writing 3 dots. So this shows that your AP is still continuing. There are many terms which have not written there. And if I ask the number of terms here, 1, 2, 3, 4, 5, 6, 7, and it is still going and you don't know till where you're going to write. So this is going to be an infinite. So small difference. Okay, now let's solve the example questions. So for the AP, 32, 12, minus 12, minus 32, write the first term A and the common difference T. Okay, so the first term is always the first term of the series, so that is 32. The common difference is given by A2 minus A1, or you can also find it by subtracting A3 minus A2, or by subtracting A4 minus A3. So here I'll be subtracting the second term from the first term. So that is 12 minus 32, that is minus 20. Right? Yeah, minus 20. This is the answer. Next, which of the following list of numbers form an AP? First, you have to see which of the following form an AP. For that, what you have to do? You have to find the common difference, and those common difference must be same. So that is A2 minus A1 must be equal to A3 minus A2. That must be equal to A4 minus A3. So here, so this is your A1, A2, A3, A4. So what about A2 minus A1? That is equal to 10 minus 4, that is equal to 6. What about A3 minus A2? 16 minus 10, that is again 6. And what about A4 minus A3? That is equal to 22. minus 16, which is also 6. So here this condition is satisfied, the first case. So this is an AP. This is an AP. Now let's move on to the second one. Okay, for the sub question, we'll go through it later. First, let's see which of the following form an AP. 1 minus 1 minus 3 minus 5. So for this, first I'll find out the common difference. A2 minus A1 is equal to minus 1 minus 1. That is equal to minus 2. Then A3 minus A2, that is equal to minus 3 minus of minus 1, which forms minus 3 plus 1, that is equal to minus 2. Then A4 minus A3, that is minus 5 minus of minus 3, that is equal to minus 5 plus 3, which is equal to minus 2. So even this is forming an AP since this condition is satisfied. So this is also an AP. Now let's move on to the third question. Minus 2, 2, minus 2, 2, minus 2. So what is A2 minus A1 here? 2 minus of minus 2, that is equal to 2 plus 2, 4. A3 minus A2, that is equal to minus 2 minus 2, right? Yeah. So that is equal to minus 4. So here A2 minus A1 is not equal to A3 minus A2. So this condition is not satisfied in the third case. So this is not an AP. This is not an AP. Now let's move on to the fourth part. So in the fourth question, okay, so here A1, A2 minus A1 is equal to 1 minus 1, that is equal to 0. A3 minus A2 is also equal to 1 minus 1, that is equal to 0. Next, A4 minus A3 is equal to 2 minus 1, that is equal to 1. So here A2 minus A1 is equal to A3 minus A2. Okay, this is okay. But it is not equal to A4 minus A3. So this is not okay for us. So this is also not an AP. So here all the common difference, it must be same. It must be a fixed number. So here if it is 0, 0. But here it is plus 1, which is not okay for us. Okay, that is not okay for us. So here your second one and fourth one is not an AP. Only your first two numbers are AP. Now let's go through the sub question. What is a sub question? If they form an AP, write the next two terms. Okay. So what was the common difference here? For the first one, the common difference was equal to 6. So what 22 plus 6 is 28 and 28 plus 6 is 34. Okay. So this is your term. Next two terms. In the second one, the common difference D was equal to minus 2. So minus 5 minus 2 is minus 7. Minus 7 minus 2 is minus 9. So these are the next two terms. Now let's start with the exercise 1.1. Okay, I'll be solving this whole exercise. Okay, for the similar questions, I'll be just solving the first two and the rest you can solve it by yourself. Okay, because there are many similar questions in this exercise. Now the first question, in which of the following situation does the list of numbers involve make an arithmetic progression and why? So you have to check whether the given situations form an arithmetic progression and you also need to give the reason whether it's forming or not. The first question is the taxi fare after each kilometer. When the fare rupees is rupees 15 for the first kilometer and rupees 8 for the each additional kilometer. Okay. So for the first kilometer, if you travel only 1 kilometer, if you travel just 1 kilometer, then what happens if you just travel 1 kilometer? Then your taxi fare is rupees 15. But what happens if you travel 2 kilometer? For the first kilometer it's 15 obviously, but for the next kilometer you will have to pay rupees 8 additional. So it becomes 15 plus 8. Now if I have to travel 3 kilometer, then for the 2 kilometers it's normal 15 plus 8 and for the next, for just 1 kilometer you will have to pay again 18. So for the fourth kilometer it becomes 15 plus 8 plus 8 plus 8. So here if you observe, in this case I'm just adding 1 8. Here again I'm adding 8. So here again I'm adding 8. So yes, this is forming an AP. What is the reason? The common difference here is equal to 8. And if the common difference is constant, okay, then whatever be the case, it doesn't matter. If there is a common difference, then it forms an AP. Now let's move to the next question. In which of the following situation does the list of number... Okay, same question. The second question is the amount of air present in a cylinder when a vacuum pump removes 1 by 4th of the air remaining in the cylinder at a time is. Okay. So initially, consider I have a container with this full gas. Okay. Now the pump is removing 1 by 4th of it. Then how much gas is left? If 1 by 4th is removed, then only 3 by 4 is left. So here I had V. So now only 3 by 4 V is left. Now again, from this you are removing 1 by 4. If I remove again 1 by 4 out from this, so how much it will become? So then it will again get reduced. Not 1 by 4 of this volume. So 1 by 4 of 3 by 4 is how much? It is 3 by 4 P into 3 by 4. Okay. 3 by 4 of this much you have to find. Okay. If you are not able to understand, I will be explaining it with the cross multiplication method. Okay. So if I am considering the whole volume as 1, it is 3 by 4 V. Now from this I am removing 1 by 4. That is, then I have to find what is the value of 3 by 4 of it. Then if you cross multiply, it is 3 by 4 into 3 by 4 V divided by 1. So that is equal to 3 by 4 the whole square into V. So now again if I remove 1/4 of it, what happens? You are left with 3 by 4 whole cube into V. Now the next one, how much it becomes? 3 by 4 to the power 4 into V. So what is the series that you are obtaining here? V, 3 by 4 V, then 3 by 4 whole square V, 3 by 4 whole cube V. Okay, and by seeing only you can say that it's not forming an AP. If you want, you can check here A2 minus A1, that is equal to 3 by 4 V minus V. But A3 minus A2 is how much? 3 by 4 into 3 by 4 V minus 1. Sorry, minus V. So, you are again having some extra term here. So that is not okay for us. So here the common difference is not equal. So since it is not equal, it is not forming an AP. So this is not an AP. The previous case, it is an AP because we had a common difference. Here, the common difference does not exist. Next question. The cost of digging a well for after every meter of digging, when it costs rupees 150 for the first meter and rises by rupees 50 for the each subsequent. Okay. So if I want to dig 1 meter, then the cost is rupees 150. But if I want to dig 2 meters, then for each 1 meter it got raised by 50. So it got incremented to rupees 200. Now if I want to dig 3 meter, it got raised to rupees 250. For 4 meter, it got raised to rupees 300. So if you observe here, the common difference A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3 is equal to 50. So here the common difference exists. So from this you can see that it forms an AP, right? Next question. The amount of money in the account every year when rupees 1000 is deposited, so this is your principal value, and principal like is no principal at compound interest at, so they have given you the rate of interest 8% per annum. Okay, so what is, there's a formula, hope you remember this. The amount deposited is given as principal rate into 1 plus rate divided by 100 raised to the power years, right? The power n, where n is the number of the year. Okay, so what about the first year? For the first year, it is 10,000 into 1 plus r is 8 by 100 to the power 1. For the second year, what happened? It is 10,000 into 1 plus 8 by 100 to the power 2. For the third year, what happened? It got raised to 10,000 into 1 plus 8 by 100 to the power 3. So again, if you see here, okay, the common difference here, A2 minus A1 is not equal to A3 minus A2. Okay, so from this you can say that it is not an AP. You can verify if you want. Okay, it is not an AP. Now the next second question of this exercise. Write 4 terms of an AP when the first term and the common difference is given to you. Okay. So how can you write the 4 terms? They have given you the first term in the form of A. Okay, it's nothing but your A1 only. They've just given us A. So your first term is 10. For the second term, you need to add the common difference. Then go on adding the common difference. That's it. And you're done. Here, minus 2. For the next, you're going to add 0. Again, you will be adding the common difference only. So this is the first 4 terms. Next, here, first term is 4. Then you will add minus 3. So it becomes 1. Then minus 2. Then minus 5. Now here, minus 1. You will be adding the common difference, that is plus 12. It becomes 11. Then you will be again adding the common difference, that is plus 12. It becomes again you will be adding the common difference plus 12, that it becomes 35. Okay, so this is your homework question. Okay, actually when you're writing your exam, you cannot write so directly. So you will have to first write the representation of an AP, that is A1, A1 plus D, A1 plus 2D and A1 plus 3D. So this is your representation for the first 4 terms. So from this you will be writing A1 is equal to how much? 10. A2 is equal to A1 plus D. So that is equal to 10 plus 10. Next, A3 is equal to A2 plus, sorry, not A2, A1 plus 2D, right? A1 plus 2D. So that is 10 plus 2 into 10, that is 20, that is equal to 30. A4 is equal to A1 plus 3D. So that is equal to 10 plus 3 into 10, that is 30, that is equal to 40. Okay. Next one is, for the following APs, write the first term and the common difference. Okay. So again, it's very easy. First term is always the easiest part. Just you have to write the first term. Okay. So I've written for all the 3 examples, questions. Now we have to find the common difference. So common difference is how much? A2 minus A1. Or you can also go for A3 minus A2, whichever is easier for you. They've already given it as an AP, so there's no need for verifying whether all of them are same. It will be same. Okay, so here I'm going for 1 minus 3, that is equal to minus 2. Here D is equal to A2 minus A1, that is equal to minus 1. Minus of minus 5, that is equal to minus 1 plus 5, which is equal to 4. Next, here common difference is equal to A2 minus A1, that is equal to 1.7 minus 0.6, that is equal to 1.1. Okay, hope this section is also clear for you. Now the last exercise, I guess, the last question of the exercise. Which of the following are APs? Okay, now you will have to verify whether the common differences are same. So if they form the AP, you have to find the common difference D, and also you will have to write the 3 more terms. Okay. So here, since there is a shortage of space, I'll be starting from the corner only. Here. Okay. So the first one, 2, 4, 8, 16. 2, 4, 8, 16. So here common difference A2 minus A1 is how much? 4 minus 2, that is 2. A3 minus A2 is 8 minus 4, it is 4. So these two are not equal. So common difference does not exist. So what can you say? It is not an AP. Not an AP. Now, second question. Okay, here if I do A2 minus A1, I'll get 5 by 2 minus 2. So that is equal to 5 minus 4 by 2, that is 1 by 2. Now a3 minus a2 is 3 minus 5 by 2, that is equal to 1 by 2. So here both of them are same. You can also check for a4 minus a3. Okay, you will have to check. Sometimes they will make some mistakes there. They'll change the value there, and few of them will just check the first three terms. They'll not check this value whether the common difference is same in a4 minus a3, and they'll lose the mark because they'll give the same value here, but for the third case they'll change the value. Okay, so 7 by 2 minus 3. So that is 7 minus 6 by 2. So that is equal to half. So this is an AP. Yes, so this is an AP. So, okay, you concluded that it's an AP. But what is the value of the common difference? The common difference was equal to half. Right? Yes. So, it is an AP. Yes. Common difference D was equal to half. So, 7 by 2 plus half you have to do. So, that is 4. Then, plus half is 9 by 2. So, sorry. This is your next terms I'm writing. Then it is 5. So these were the next three terms. Okay. Now I guess you can solve this. This you can take it as your homework. This one also you can take it as your homework. Very simple. Now let's come to the fifth problem. So in the fifth problem, so let's find e2 minus a1. So that is equal to 3 plus root 2 minus 3. That is equal to root 2. Now 3 minus a2 is equal to 3 plus 2 root 2 minus 3 minus root 2. So that is equal to root 2 again. So again a4 minus a3 is also equal to root 2. Okay, I just calculated in mind, is also root 2. So from this you get that here the common difference is equal to root 2. So can we find the next terms? Obviously, what are the next terms here? You will be adding root 2 to the fourth term. So fifth term is 3 plus 4 root 2. Then it is 3 plus 5 root 2. And the next term is 3 plus 6 root 2. Very simple and straightforward. Here you can also solve this question. Even this question. This is also very simple. Okay. Okay, so here. Sure. This is a mistake. So this is minus half. Okay. Minus half. Minus half. So this is a question. So here what is the common difference? Is 0. So what are the next terms going to be? It is again minus half, minus half, minus half. Okay. So these two questions were in your homework. Now the next question here. 1, 3, 9, 27. Again you can see that the common difference here is varying. In the first case the difference is 2. Next is 6 and next it's even more. So a2 minus a1 is not equal to a3 minus a2. From this you can see it's not an AP. So here you can find a3 minus a2 is equal to 3a minus 2a, that is equal to a, and a2 minus a1 was also equal to 2a minus a, that was equal to a, and a4 minus a3 is also equal to 4a minus 3a, that is equal to a. So here if you see the common difference is the same, so your common difference is equal to a. Now what about the next terms? 4a plus a is 5a, plus a is 6a, and 7a. These were your next terms. Now again this is also your homework. You can just find the common difference is not the same. Okay, the next question. So here simply it's tricking your mind. So if you directly see you will say it's not in an AP, but just simplify this. It is root 2. Now root 8 can be written as root 4 into 2. So that is equal to 2 root 2. Okay. Now root 18 can be written as root 9 into 2. So that is equal to 3 root 2. Similarly, root 32 can be written as 16 into 2. This is equal to 4 root 2. Now see, here the common difference is equal to root 2. Common difference is equal to root 2. Why is that so? You're adding root 2 here. You're adding root 2. Then what about the next terms? It is 5 root 2, 6 root 2 and 7 root 2. Okay. Next term. Question. Here root 3, root 6, root 9, root 12 is given to you. Right. So in this question, again, do not forget to simplify. Root 3, it's in the simplified form, simplest form. It is also in the simplest form. 6 is also in the simplest form. Then root 9 is 3 and root 12 is 2 root 3. If you observe, it's not in an AP. It's not an AP because the common difference is not the same. Okay, again, these two questions are your homework. Okay, it's very easy. Okay, similar. You can solve all the questions in the same way. So yes, this completes our part 1. And I'll be uploading the next part 2 and part 3, in which I'll be discussing the next exercises. Thank you. Please do like, share and subscribe my channel.